Yes, I I spent quite a lot of time to feel about the topics of this lesson. So finally, I think that applying IT technologies in new applications will be yeah, one of the best topic or best name for today's lecture. In fact, we are going to talk. So today we have lots of things that is related to IT. We have lots of things that is related to computer science or coding, etc. Right? We create apps, we create games, we create VR application, etc., etc., etc. Right? So yeah, how we can use the IT technologies and create something that we need for our daily life. Okay, so I chose this topic. Hopes yeah, you know that what is the technology behind the scene, technology behind the screen. Okay, your phone or your PC screen. Okay, and then you know the structure behind, and then you know the technologies behind. So there are two ways to learn IT, CS, computer science, coding, app development, etc., etc., etc. Okay, so yeah, the first way, of course, is bottom up. Bottom up. Okay, here is bottom up. So this is the traditional academic approach or traditional teaching in university, or you would say that in your secondary school, etc. Okay. So what's going on? So the teachers, okay, the lecturer in the university, they will teach you about the coding, about the computational thinking, okay? So they will teach you about the variable first, variables, and then they will teach you about the full control. That means if, that means for, okay? That means the function call, etc. Then they will teach you about the object-oriented programming, so how you define the object, etc. So the output or the outcomes of your teacher and learning in university in year one in computer science professional. So most likely the first thing you can do is hello world, or we call it print 9. Okay. Then they will ask you to learn how to use the coding to do some logical problems or logical thinking. That is the computational thinking. So for example, how a farmer can bring a duck, or a vegetable across the river. Okay, so every time he can only carry two kinds of things, etc. So you are required to use the if, for, function call, etc. program or object-oriented programming to do such kind of programming. You cannot call the library, you cannot call the API, and then what you get is some logical thinking by using the programming skills. So you are going to type in the programming 9 by 9, and then you add a computer and then implement the procedure 9 by 9, okay, to achieve some logical question, to achieve some basic fundamental questions. So if you are the computer science student, definitely you have the experience to print the star, okay, to print the star as a Christmas tree, or you print the star as a triangle, or as a special design pattern. So it's a training how you use the coding, how you use the if for procedure call or object-oriented programming to solve some problems. Then you will be asked to learn some data structure questions. Okay, so how to use the tree structure, how to use the graph model, how to use different kinds of data structure to solve some complicated computer science problems. So after that, you will learn about the algorithm. Okay, so maybe it's about the AI, maybe it's about the computer visions, maybe it's about the security, blockchain, etc., etc. After that, so you are able to build some application. For example, you can build some web applications, you can build some app, you can build some games, VR, blockchain, IoT of thing, etc., etc., etc. Okay, so bottom-up approach is a traditional approach, is good. Okay, but for lots of the students, even in our computer science student, so they find difficulty in learning the computation thinking. Okay, so one of the yeah, most difficult subject in our department is the fundamental programming. It's hard to add a computer and think the problem line by line. And then our students have no idea why I need to solve this kind of IQ, okay, this kind of logic questions by using the programming. So they are not interested and they are not motivated to do it, okay? And yeah, it's a really long time to study the programming, and finally you can do some applications, VR app or games, etc., etc. It's really difficult. But it's good that yeah, now you can have some top-down approach. Top-down approach. So fans for this 30 to 40 years development. Okay, so studying computer, you need not to start all the things from zero. You build the application, you need not to build all the things from zero, because there are lots of the people. They create lots of the interesting library. They create lots of the framework for you. Okay, so there is another approach called top-down approach. Okay, so top-down approach means that I will create the app. Okay, I will create the apps. Okay, by calling some framework, by calling some library, or by yeah, I will say that copy some of the program. Okay, copy some of the program. Okay, so only a few programming lines, and then you can do a really complicated program, because lots of the word behind the screen is handled by the others. Is handled by the other libraries or other firmware algorithm, etc. Okay, so what you are going to do, you do the interface. So limited word with lots of interesting application. So this one is the top-down approach. So after you have built a web, whatever is web, app, game, etc., VR, etc., etc., etc. Okay, so you want to know more behind the screen, and then you learn better algorithm. You will try to improve your data structure technique. You will try to improve your coding technique. Okay, so this kind of top-down approach, we call it studio-based learning or problem-based learning, etc. So we try to create an application and learn what is the technologies behind. Okay. In this course, we do the same thing. Okay, we do the same thing. So wherever you are good in computer science or law, or wherever you're good in programming or logical thinking or not, okay, you can still create some interesting apps. Okay, and then if you're motivated, and then if you are interested in this kind of approach, you can learn more what's going on behind. So I guess you are quite familiar with these kinds of the IT product structure. Okay, IT product structure. So when you go outside to work, so definitely you will not start the things from zero. Okay, so most likely you'll find some framework, you'll find some reference, you'll find some source code, you'll find some structure of the program, okay, of the program first, and then you will start. So today your developments will be like that. So somehow, or I will say that's when you become a programmer. So most likely when you go outside to you're a junior web programmer, you're a junior app programmer, you're a junior programmer, you're a junior project assistant, something like that, right? So what you are going to do is you try to divide your product into two parts, okay? So the first one is your part. So most likely your part will be the interface and logic, okay? And then the second part you will find out are different kinds of platforms, okay, to support your work, okay? So I guess you are quite familiar, because when you study about the database, okay, when you study about database, so you will find a database management system, DBMS, okay, DBMS. So DBMS is here, okay, so it's a platform. It's a platform, okay. So yeah, DBMS, you can name some quite well-known DBMS. For example, if you are junior, if your application is not so serious, right? So somehow you will use MySQL. So if a business solution, so you will use the Microsoft SQL Server. Okay, so if you are big company enterprise, or you work in if you work in our Hong Kong government, most likely you use the Oracle. Okay, so if you use banking, you use the DB2, okay, or IMAX, okay, IBM solutions. So why you use this kind of DBMS? Because DBMS, there are lots of logic about the transactions. Okay, so you need to handle the locking, you need to handle lots of the things about the I/O. As a junior programmer, we can't trust you. Okay, honestly, we can't trust you. Okay, so most likely we want to guarantee the infrastructure. We want to guarantee the backbone is stable, is safe enough. Okay. So we'll find some professional solutions to replace your work. So what you are going to do, you will go to do your part. Okay, so you will connect to the database. Okay, you will connect to the database, and then provide an interface. Okay, so mostly the interface maybe is a web programming. So you have you can use the loop.js. Maybe you can use the PHP. Maybe you can use the .NET solutions. Maybe you are working in banking, so you can use Java, okay, J2EE or Servlet. So you can also include some interesting or fancy interface, some interesting JavaScript file, so that you need not to handle lots of the interface, because nowadays for the web program most likely, so yeah, the interface are almost the same, right? So you have a similar app interface, you have a similar web interface, etc. So maybe you will include React, maybe you can include Vue, etc. Right? So you use different kind of JavaScript framework to help you to speed up the work. Okay, so your part is limited. So today as a junior programmer, so it's quite easy to do because there are lots of well-known and then ready to use solutions. So you can use them. Okay, so your IT product, even you are a junior programmer, we can still trust your IT product. So that's the case. Okay, nowadays that's the case. Of course, what you have learned in program fundamentals or other course. So it will be you will still use it, but perhaps you go to some research level, you want to go deep into SDK or become the senior, or if you work in a big company, okay, maybe 10 years ago, so you know this kind of things, okay, because you have the mathematics background, you have the data structure and algorithm background, and then you know what's going on, so you can move into some senior position. Okay, but again, it's a yeah, this project, so most likely you need to build up your solutions and it's ready to use. Okay, so we will also have similar structure, so we'll break your product, okay, your product into two parts. Okay, interface and logic, and also the platform. Okay, so we will use the platform as a service, and most likely we'll use the Google Visions, we'll discuss later, and also Dialogflow. Okay, Go Visions and Dialogflow, both of them are, we can say, a machine learning. Okay, they use lots of the machine learning approach to solve the computer vision CV problems and to solve the NLP, natural language processing problem. Okay. So there are lots of ready to use library API, and then you can call, and then you can give the ability about object recognition, ability about the chatbot. Okay, chatbot. To your product by calling the API. Okay, so what's your job? So you are going to based on the needs of your solutions. For example, you want to build a Hong Kong dollars, recognize the Hong Kong dollars, or you want to add like say training and then talk with the ID children, right? So you want to help them to train or to speed, okay, to please encourage them to speak instead of using the MC questions. Okay, so your work is build a interface, okay, together with the logic. Okay, that means the gameplay. Okay, interface and also the logic. Interface is not only about the icon, it's not only about the graphics. It also includes how you process the input from the user. That means, for example, chatbots. So the interface includes how you capture the audio's input into the Dialogflow and then process the audio input and return the data. That means maybe it's testable speech again to the user. Interface also include, for example, you are using the comparison. So you use the camera to capture the image input and then process and return the output. Okay, logic, that means the flow of your game. Okay, that means the flow of the game. So interface and logic together is not only about the graphic, it's not only about the buttons. Okay, it also contains lots of things about the event-driven programming, about how you handle the input. And then what you are going to use is Unity 3D. Okay, so it's another well-known game engine. Okay, so this one is pretty good for the 3D programming. So somehow, again, lots of the game physics, lots of the collision detects, lots of the logic is ready, and then you can just call it. Okay, if you find something you want to use, or if you find some graphics 3D model that you want to use, there is a asset store. Okay, and then you can put input the object from the asset store into your program. Again, this is pretty good. Okay, if you do not know what is Unity 3D, perhaps we'll spend another lessons to talk about the Unity 3D before we start our lessons. Okay. So as I have mentioned before, there are lots of library, there are lots of support that is created by the others, okay, by the IT professionals, by the IT company, etc. So most likely today we seldom, or I would say that we never create a program or create an IT solution from zero. That means line by line, line by line, and then character by character. We will not do that. Even a big company, so they will try to call the library, or they have some framework for their developments. Okay, so or somehow if you wish to go to IBM and then you go to the Google's or you go to the Microsoft, that you are going to create some API, you are going to create some library for the other to use. Otherwise, we will not create the program from zero. So we will select different kinds of support from the IT company. Okay. So how to select the support, right? The first thing you need to know that is what level or what kind of things, okay, what kind of things I need to create for my IT solutions. Okay, what kind of things I need to create for my IT solutions. So there are different levels of the support that we can use. Is SAS, PAS, and IAS. Okay. SAS means that software as a service. Okay, software as a service. That means it's a software. Okay, that means a software. So Gmail is a software, Dropbox is a software, Google Apps is a software, etc., etc., etc. Okay, so somehow, you can still use them as part of your service. For example, if you want to communicate with others, so somehow you have a button and then redirect the things to Gmail. Okay, or if you want to store something, perhaps you will put it in YouTube, and then inside the app you will load the movie from the YouTube, etc. Okay, and in these lessons, or most likely for most of the application, we will use the PAS. Okay, PAS, platform. Where's my pen? Yeah, sorry, platform as a service. Okay, platform as a service. That means it's a tools or SDK, standard development kits, or is a library. Okay, it's a library for you to create the software. Okay, for you to create the software. So there are lots of the library you can use. For example, they can provide the user interface, they can provide the machine learning, they can provide the comparisons, they can provide the chatbot, they can provide lots of different library. Okay, that you can use. Okay, that you can use. Okay, so there are a couple of examples. For example, we are going to use Google. Okay, Google Service. Okay, Google Service. Microsoft, they also provide a similar thing. For example, Microsoft Azure. Okay, or you can go to AWS, Amazon. Okay, Amazon Web Service. They also provide similar service. And if you are in China, so Tencent or somehow about the Huawei, so you can ask the service from them. So they also create similar platforms. Okay, so they provide the SDK for you, they provide the library for you. So how they can earn money if you use their service. Okay, so it's for example, you use their comparisons to recognize an image, right? So you need to pay for each transaction, okay? Okay, for example, if you have used for more than 1,000 transactions, 1,000 times, okay, so you need to pay for them, okay? So they charge for your usage, okay? They charge for your usage, or you can say it's charged by usage on demand, okay? So PS also, besides the SDK, PS also provides you the infrastructure, okay? Infrastructure. So infrastructure means that it's a hardware, okay? Okay. For easy understanding, it's a PC or it's a server, okay? It's a hardware with the OS, with the network. So a dedicated hardware is put inside dedicated data center, okay? Provide a internet access, and then you can connect to a server to do the work, okay? You need not to turn on your machine at home, and then you need not to turn on your machine in our lab, okay? So all these kind of things you can depends on trustable data center, we trustable server, we trustable hardware, okay? So they have the network, they have the hardware, they also provide you the OS, okay? So that's why we call it virtual machine. Okay, so you have the GPU, you have the memory, you have the network ready inside, okay? So if you want to enlarge your usage, or you want to enlarge the support of your service, so you can just go to the IaaS, okay, infrastructure as a service, and then take, yes, I want more computation power, or I want more network, etc. I want more bandwidth, etc. So again, AWS, Google's, or Microsoft, or Huawei, or Tencent, they also provide such kind of things. So here is a graph to recognize, okay, to recognize what is SAS, and then what is the PS, and also the IaaS, okay. For the SAS, okay, so most likely you cannot change here, okay, SAS. So most likely you cannot change anything, okay. You cannot change anything. You cannot change the flows of programming. You cannot change the structure of their program. What you can do is you use their service. Okay, perhaps you can change the interface, just like the Gmail. You can change the background of your Gmail, etc. Okay, so this one is SAS. And other is platform as a service. Okay, here platform as a service. So they provide the hardware for you. So here is the hardware, okay? They provide the OS for you. They provide the middleware, okay? That means the library, runtime, etc. Okay? They also provide the storage for you. So you can use their platform to create something, okay? To create something that is interesting. So we are using Zoom now, right? Or somehow you can also using Teams. Zoom or Teams, it can be a SaaS, okay, software as a service. So you turn on the Zoom, you turn on the Teams, and then you enjoy the video conferencing. It can also be a PS. I use the Team server, that means the Microsoft server, or I use the Zoom server. Okay, I use their bandwidth, I use their infrastructure, but they also provide a SDK. Okay, they also provide the SDK for you to edit their interface. Okay, that means I can create the interface again, or I can combine the Teams client's interface or Zoom client interface with the other. For example, we are using Blackboard, right? So we can combine Zoom into our Blackboard, okay? Or even we can combine Zoom into our Teams, into different kinds of learning management system, LMS, etc. Okay, so this one is one of the example. So infrastructure as a service, okay, infrastructure as a service. So they will provide the hardware. So you see that they will provide the hardware, and then you have the possibility to change your to build your OS or other kinds of things. Okay, so it's okay. You just remember we are here, PS. Okay, and is a is a common development development style nowadays. Okay. So the API that we'll use in this project, application programming interface, that means library, that means that means the API that you can call and then pass the input to them, and then they will process, and then they will return the output for you. Okay, the API that we use in this project is Google Cloud Visions. Okay, Google Cloud Visions is powered by the Vision API. Okay, so you can download their API, you can download their library, and then you can download the trained model to run. Of course, they also provide the server. They also provide the infrastructure for you to use. So somehow you can use their infrastructure, okay, and then to process the image or to process the things that you need. But of course, because you spend their server, you spend their computation power, they will charge from you. Okay, so there are two ways to interact with the Google Vision API. The first one is, of course, you download into your local host, and then you run the server, and then you run their program. Another thing is why it says cloud solution, why we say it's PaaS, because they also provide server. So you need not to set up anything, you just call their service, and then they will return the things for you. But you need money, you need to pay to Google. Okay. So Google Vision API. Okay, it's an API, application programming interface. So that means that you can call the library. Okay, so the library is, you can download the things that you can also call the Google service. Okay, so they provide the pre-trained machine learning model. That means you need not to do any training. Okay, you can just ask the service and say whether it's a dog, whether it's a cat, whether it's a $10, $20, $100, etc. Right? So you can ask the Google, and then they will return the value for you. So it provides two different kinds of APIs. Okay, one is REST, another is RPC. Okay, so REST means that it's a representational stage transfer. Okay. So RPC means the remote procedure call. Okay. So RPC is a little bit old, REST is a little bit trendy, but both of them, they are HTTP API, and then you can use the JSON or XML, okay, to make your input. Okay, so today most likely we use the JSON. XML again is a little bit old-fashioned. Okay, XML is a little bit old-fashioned because lots of the people, lots of the program, they hate structure. Okay, it's quite complicated, and then you need to do lots of the tracking, and then yeah, the overhead is quite large. Okay, because there are lots of start tab and tab, etc. JSON is easier. So what mean JSON or XML file? You prepare this kind of JSON files. Okay, prepare this kind of JSON file. So you will include you say that is a request, and then you will include the image source. Okay, so you will find some way to put your image. Okay, so you have the URL, and then tell me that what kind of things you want to ask. Okay, so there are some parameters inside, so you can read more in our labs or later. So you pass it into the Google Vision API, and then they will give you the response. Okay, so the response most likely, because it's a pre-trained model, so they will return they will return the findings for you. For example, they will return whether they think that means the label. Okay, the label of the image, they think it's a dog or is a other kinds of animal or not, and then they will return the confidence to it. Okay, the maximum is 1. Okay, so this one is 0.97. That means they are quite confident, say that the image here is a dot. Okay, so yeah, there are two different kinds of APIs. Of course, you can use the remote procedure call. So remote procedure call, they give you get post. Okay, get post. Okay, so if you are using the REST, okay, so you, beside the get post, you can also use the put, delete option, patch, etc. So it provides more flexibility for you to run the program. in the server. So most likely today, lots of the people they use REST rather than the remote procedure call because they can provide more function for you to use. So honestly, what is Google Version API is doing is assign the label to the image. Okay. You need not to train it because it's pre-trained, and then they have millions of predefined category. Okay, millions of predefined category inside it. So most of the common object you can find it inside the Google Vision API. Even it's not a common object. For example, they can determine different kinds of butterfly. They can determine different kinds of insect, fish, tree, flowers, different kinds of natural things. So they are keep on updating their category. So they are keep on updating the power of computer visions. Okay. So besides give the label, they can also detect the object. Okay, so they can detect multiple objects. Okay, they can detect multiple objects in the same image. They can determine the face, whether it's a human face or not. Then they will try to put a rectangles on your face. They can define the task. Okay, whatever is a print task or handwriting task, and then later on we'll discuss the OCR AI. So it also provides lots of the function for the computer to recognize or understand the skin at the situations. Okay. Yeah, it also build variables metadata, so it try to understand the information behind the image. So Vision API provides you the automatic labeling. So there are some pre-trained machine learning model for the computer visions, and then they can provide all the well-known labeling for your image. Okay, but most likely you want to have some own labeling. Okay, maybe you want to have more discussion about object, or maybe you want to dedicate a certain style, go deeper into each image. Okay, so somehow you need to change your personal model, and then to change your personal computer vision or machine learning model, you need AutoML. Okay, AutoML. So AutoML is like that. You prepare a huge amount of image. Okay, you prepare a huge amount of image with labeling. So you told what is the meaning of this image, what is the meaning of that image, etc. You provide the label for that. And then you go to the AutoML. AutoML will help you to train the model. Of course, yeah, of course it costs money because it's a Google service. And then you train the model, and then you can deploy into deploy the trained model into the other application. If you want them to host your service, they also provide the server so that you can use your REST API to call the service. Okay, to call the service here, and then your image can have your own label. For example, here we have a comparison between the Vision API and also the AutoML. Okay, so here it's probably I would say that is pretty good. It's pretty good. So for example, this one is property. Okay, this one is property, and this one they tell you that is a sky, house, something like that, right? So it's pretty good. But somehow, if you want to have more understanding about this image, you can use the AutoML to do the training instead of Vision API. So you can train it is a modern building. Okay, you can train it as old building, Victorian buildings, and so on and so on. Okay, so you can put your own label into it and then do your training. Okay, so it's pretty good. Okay, and sometimes it fits your own need. So in short, AutoML means that you can train your own custom image, okay, and build the machine learning model. Okay, they provide the GUI for you, graphical user interface for you. That means this one. Okay, this one. They provide the graphical user interface for you to do all the training. The only thing you need is only prepare your data set, image and label pair, image and label pair. Okay, then yeah, of course you can customize your model for the accuracy and then for the latency and the size. Okay, so yeah, you can control about the accuracy. Okay, and you can also export your application to the cloud service or download it to your own device and use. Okay. So here is the comparison between the AutoML and also the Vision API. Okay, yeah, both of them they can use the RAS or Remote Procedure Call API to call it. Okay, and then for the AutoML, you can also have the graphical UI because you need to train your own model, right? You need to train your own image and also your own label pair. So it provides the UI for you. Okay. Vision API they can classify the image by using the pre-built labels. And the machine learning, you can have the custom labels for you to use. Okay, so that's the difference. Pre-train the model with pre-trained labels, or you want to have the customized label and customized image for you. Okay. They can, yeah, both of them, they provide the labeling system. They return the name of the labels and they also return the accuracy. So when did you need to use the Vision API and when do you need the AutoML? Okay, so somehow when you, of course, you have some customized image. Okay, for example, Hong Kong dollars, right? You have 150, 10, or etc. Right? So when you use the Vision API here, when you use the Vision API and try your data set and you find there is some problem of using the Vision API, so you build your AutoML. Okay, you build your own data sets. You build your own machine learning to train it. Okay, and of course you can use both. Okay, you can use Vision API together with AutoML. Okay, so that you can compare the result inside your interface and inside your application, and then decide which result you want to display, or you can combine the result of Vision API and also the AutoML to your user, or you make your own decisions. Okay, so you can call both of the library and then return the result first, and then yeah, just let your program, let your logic to decide it. Okay. And then for the AutoML, it can be integrated in Edge. Okay, Edge computing here. So what's Edge computing? Edge computing is somehow, for example, you are working with some IoT, okay, IoT device. The IoT device, they have lots of the high frequency in I/O, input and output. Okay, so you want to ask the server in a very, very short time, right? And then you want to yeah, with low latency here is better. Low latency, okay, high transaction I/O, and then you want to have a high accuracy model, so you need a dedicated machine. Okay, instead of you build a huge machine for the or you call the Google service, so you have separate machine, separate server to do it. So it's edge computing. Okay, so you process into a dedicated computer device first, dedicated server first, and then you go to ask the Google service later, so you can reduce the latency. Okay, so this how you this how edge computing is doing. Because the machine learning model is created by yourself, is custom, so most likely it can only, yeah, machine learning here, they can only detect the object. Okay, but with Vision API, because it's pre-built model, and then there are lots of different functions. So as I have mentioned before, so you can produce the product search, so they can return the product category, or they can return the branch of similar items. Okay, so if you are using Taobao, or you are using what kind of things, eBay, okay, or Amazon. So you take a image, so they can use the image to find a similar product to you. So that's another search. And then the Vision API, they can also detect the print and handwriting tasks. That means the OCR, okay. Optical character recognition. So in 30 or 40 years ago, the OCR most likely is a you use the scanner to scan the printed copy, and then they can return the ABCD, they can return the task for you. But today, the OCR, they change a lot. So they change it into OCR AI. Okay, so there are lots of machine learning method put into it. So they will not only bound by the scanner, so you can use a camera just like the camera on your mobile phones, right? They can use a camera, take the image, they do the image enhancement, so they scale, rotate your image, and then what is the meaning of AI? So they can understand the task, the image that you have scanned, okay, and then put it into the correct form. For example, you scan a form about your task or about your I don't know. We have lots of forms, right? Especially during COVID-19, so they can know that this data that you input is date, this data that you input is name, this data that you input is address, okay, for example. And then also our AI will turn the scanner test directly into the correct data format, okay, or correct data fields, okay, correct data fields. For example, they would put the name in the name field, put the address in the address field, put the date in the date field, etc. So this one is OCR AI, is speeds up all the process. So there are lots of application area in OCR AI. For example, you can when you go to the shopping mall, you save the receipt, and then if you scan the receipt, you can do I don't know exchange for some goods or exchange for some point. So this is one of the popular applications, okay? And of course, the Vision API, they can detect the face. They can recognize the product or recognize the place, and then recognize the image attributes. For example, whether you need a shop, okay, shop locations, okay, or they can return a color for you, okay. So the general history, etc., etc., etc. Okay. And yeah, the most important thing is about the pricing model. Okay, Google Vision pricing model. Google Search is not free. Okay, even for the search. So if you are a heavy user of search or heavy user of Google Gmail, okay, so you need to pay and then you need to charge. Okay, so most likely if you are not heavy user, so most of your service is free. Okay, first 1,000 use per unit is free. But for our project, maybe you will more than 1,000. Okay, because for each transaction is charged for you, and then the free pricing maybe you have different Google service, and then they will share the free service from you. Okay, so what I recommend, the first one is for each group or for each student, you create a new Google service. Okay, you create a new Google account to enjoy the free service and try to separate your work. Okay, you have development account and then you have your personal account, Google personal account, so that you can separate your work, your personal work, with your other developments. Okay, that is quite important because, for example, you use AutoML to train the model. It should for Hong Kong, it should be charged around 300 something if you want to train the Hong Kong dollars. Okay, if you want to change the Hong Kong dollars. Okay. And then if you request for the server to host the machine learning model, that you do not want to use your local computer, local host to do it. So exactly remember, it should be Hong Kong dollars 200 every day. Okay, for every day you need to pay Google $200. Okay, it's really expensive. Okay, honestly, it's really expensive. Okay, so try to make a good use of Google free credit. Okay, and also, always remember to create new account if you really want to do it. We will teach you how to monitor the usage, how to monitor the money. If you use more than the free credits, please stop the account and please maybe you can use the other free account to do it again. Okay. So beside Google Visions, okay, Google Vision API. So somehow there is another platform, okay, that is ready to use, and then it helps I would say that's non-computer science student or non-programmer, okay, to start to learn what is machine learning, okay, and then it's also provided by the Google. It's called Teachable machine. It will not be yeah, you will not be included in this course. But if you want to know more, so after the introduction, you can try. Okay, it's quite easy to use because they have a user-friendly interface, graphical user interface. GUI for you to interact with the machine learning, with the algorithm of Google. So again, it's zero programming, so you can just click, and then you can return the output. Okay, so it's fast, and then it's pretty comprehensive. Okay, so for your additional, okay, for your personal interest. Okay, Google Teachable machine. Okay, so again, teachable machine means that is machine learning. It doesn't mean that it's going to teach you to do something. So you are requested to provide the data and then teach the machine to do something. Okay, so it's really funny names. It's produced by Google. Exactly, remember it should be 2018 or 2019, something like that. Okay, it's the Google free, no coding, deep learning creation web platform. Okay, platform. So it's a PaaS. That means you can use this platform to use their deep learning model. Okay, to use their deep learning model, and then train up for some machine learning model to create a web application to fulfill your need. For example, you can, yeah, just like here, you can recognize the image to see that to continue the interactive story, or you can provide an image to teach the student whether they have wear a mask or not. Okay, so yeah, the machine learning can determine the children has a mask or they do not have a mask. Okay, so you can do this kind of the training. You can change image, audios, or pose. Okay. So after you have trained the model, you can put into Scratch. Okay. I know that Scratch is not say that one of the interface that you can use. Okay. So you can also push the train the model into Pilot. Okay. Into the other programming platform, for example, Python. Okay. For example, Python or Unity or C# or Java or other kinds of web application, for example, PHP, etc. So the step is you prepare image, okay? You prepare image or you prepare some videos, okay? Image or videos, and then you tell what is the class, okay? What is the class? For example, this one is belongs to the full body of a dot, and then this one belongs to the face of a dot. So you give them the labels, okay? You give them the labels. That means we will say that expected outcome, okay? So you gather the informations, okay, and then you need to press a button. That means to train the model. Okay, train the model. So the Google Teachable machine, they will run the deep learning behind. Okay, it takes few minutes. It takes a really short time. I will explain this technique to you later. Okay, and then you can export the model here. Okay, you can export the model, and this model can be used by different kinds of web applications or app applications. Okay, so similar to the lab that you are going to do. So you are going to capture a sort of videos, okay, a sort of videos, and then you are going to give them the labels of this set of image. Then you go to a training, and then you preview your output. So if you say that if you accept the output or accept the accuracy of the output, right? So you can export the model into your Scratch or into different kinds of programming language, okay? If you do not accept the accuracy, so somehow you can retrain. So you need to prepare another set of videos or you need to prepare another kinds of image to do it, okay? And in this course, it's quite special because so you also need to involve the student or the parents, most likely the parents or teachers, so that you need to teach them how to train the model, okay? Because you cannot send your physical object to their home or to their classroom, okay? Okay. For example, you are going to teach them hamburger, right? So perhaps you are in UK, perhaps you are in China, perhaps you are in somewhere else. So you cannot send the hamburger to their classroom or to their homes. Well, okay. So what you are going to do is for every lessons or for every training. So you need to teach them, hey, it's time to get all the physical object out, okay, physical object, and then ask the teacher or parent, train the model first, okay, and then they export the result, put it into your applications, and then run it, okay. But don't worry, you have enough time to do this kind of practice. So as I have mentioned before, this is the power of Google Teachable machine. Okay, so somehow you can input the image, you can input the videos, and then you can input the audios. Okay, so you can recognize the image, you can recognize the sounds, you can recognize the pose. Okay, so you can do such kind of things. It's a really funny applications. So this is one of the interesting example or interesting project. Okay, so don't think that the teachable machine is only for fun and is only for leisure, etc. Right? So some of the IT professionals they use teachable machine to change the case of COVID-19. Okay, they collect lots of the CT scan of the lung. Okay. Okay, so they collect, as I remember here, 53 CT scan of the lung that they have the COVID-19. Okay, and they also collect 60, okay, 60 CT scan image that they do not have the COVID-19. They put the labels and then they put all the image into the teachable machine and train. Okay, and trained. Okay. So of course they train the model and success, and then the result is quite amazing. Of course, it's a normal people when you see the CT scan of the confirmed case of COVID-19, right? You definitely can find lots of the spot inside your lung, etc. Okay, so the train result is quite good. Is if is they have the COVID-19, okay, and then throughout the CT scan, okay, I can confirm is a COVID-19 case, the percentage, the accuracy is 85%. 85%. For the low COVID-19 case, the accuracy is 83%. So here, 83 confirmed case. Okay. So 45, I can successfully find out they are COVID-19 case, and then only 8 of them are fails. Okay, so this is called false positive. And then for the long COVID-19 case, so if they do not have the COVID-19, and then 50% success. Okay, so only 10 case are fails. So this is false negative. So this result is quite good, right? So you can also do this kind of settings, or it's not only about the IT application, it's not only about the do it for the IT or MLT student. For example, if you are environment science, right, or if you are somehow about some for safety. So if you have collect enough data, you can also put into this teachable machine and then try. Okay, it's easy to use, and then you can generate lots of professional. Okay, so you see, so the graph and also the accuracy, right? So you can generate lots of the professional output and then put it into your report. Okay, so nowadays doing a research is not so difficult. Okay, we have lots of the tools for you to come up with the result. The only things you need to do is prepare the data for me. Okay, prepare the meaningful data for the machine to learn. So after we talk about the application area, so Teachable machine is only application area. They have the platform, and then they provide you to create some application. So it's a tools for you to use, and then here we talk about the theory part. Okay, so we know more about machine learning. Okay, so Teachable machine is a platform for the machine learning. So what is machine learning, right? So here we talk about the history first. Okay, having start with the history, you know what's going on, starting from the very beginning. So we have the computer system around 1950. Okay, around 1950. So at that time, we only have computer for the army and only have the computer for the enterprise. So most likely they are mainframe system, and they handle about the banking, they handle about the task problem. Okay, there are lots of calculations about the accounting and about the task. Okay, and later on around 1980, so we start to have our personal computer PC. Okay, and of course Mac. Okay, and then we continue to enjoy more and more technologies. In 2010 here, so we have our smart device, and then everyone today we have more than 5 to 6 personal computer or electronic device or smart device. Okay, in 1950, so someone predict that there are only five mainframe inside the whole world. Now I will say that for all of we guys, we have more than 5 device. Okay. So when we have the computer, so we start to process some banking problems. Okay, so there are lots of the things about calculate the interest, about calculate the task, etc. Right? So there are lots of if then there are lots of case that we need to handle by the computer. When there are lots of different case, there are lots of different rules. So we need some algorithm to help us to manage the rules. Okay, just like in the library, so you have lots of the books, right? So when you have lots of the books, so you need to have some system to help you to manage the book. Okay, to help you to manage the book. For example, the index of the book, so that you can find the book inside the library easier. Okay, not just search from the computer. So you also need a useful or meaningful indexing system to put the index, okay, to put the book number on your book, okay, so that you can find the book inside the library. And then we also need to have a good management system, how to manage the if then rules, how to manage the rules. So this is why we have the AI, artificial intelligence, okay. At the very beginning, we only have the AI to handle the rules, so we have the rule-based system. Okay, so if you are a computer science student, definitely you know that when you need to match lots of if-then rules. Okay, so you have the tree approach, you have the graph model approach, or somehow you have the forward chain or backward chain searching approach, okay, to help you to fire the rules, okay, to help you to manage the rules, okay, so that your rule-based system or your rule base will not be messy, okay, will not be messy, okay. And then, yeah, when the computer technologies continues to develop, so there are lots of problems that we find that the computer is not easy to handle. Most likely the computer only can handle 0 and 1 problem, right? 0 and 1 problem. But somehow in our daily life, there are lots of things that is not 0 and 1, okay, 0 and 1 problems. For example, I would say that today is really hot in Hong Kong, okay, today is really hot. But how you define the hot, okay? So hot, maybe someone say that 20 degrees is hot, but someone say that 30 degrees is hot, but someone will say that 33 or 34 or 35 degrees is hot, okay? So so how you define the hot or how you define the cool, so everyone they have different kinds of standard, okay? So this kind of problem start to in computer field. So we need to find out some solution for us to handle these kinds of situations. Not only 0 or 1, so there are lots of different kind of degree of variables. Okay, not only true or false. So we develop different kinds of AI. For example, we develop fuzzy. Okay, here we start the fuzzy, And then Fuzzy try to combine the statistical model, try to combine the normal distributions or different kind of statistical model into true or false, okay, into true or false, into 0 and 1. So it gives some degree of the computer to think about the problem, not just black and white 0 or 1 problem. So you have the certain degree to prove that is true, or a certain degree that is false, okay. So Fuzzy is something like that. It combines the statistical model, it combines the statistic into the computer system, okay. Of course, there are lots of different kinds of AI here, okay. And starting from 1980, because lots of the people, they start to use the computer. We have the personal computer. So with the new technologies, we generate new problems. So there are lots of junk email. Okay, there are lots of junk email, and then we start to think: is there any method? Okay, is there any method to filter out the junk mail from our mailbox? And because every day there are new junk emails, so you cannot use a traditional if-then-else approach to analyze the junk email. Okay, so every day you need to have some new methods. Every day you need to analyze the new content of the junk email. Okay, so it starts in machine learning. Ask the computer, ask the machine, okay, to learn the content of the junk mail, okay, and then filter out the junk mail for us. So that's the start of the machine learning. At the very beginning, the machine learning model is really stupid, okay? Somehow we say that the rule-based system, or we say that the if-then-else system is more and more better than the machine learning. They can only deal with some stupid job. For example, they can find a way to escape from the maze. We call it pathfinding. Okay, so most likely at that time, the machine learning model, they are only deal with the pathfinding. They are only deal with some junk email problem. They can do a little. They can only do a little bit things. Okay, but around 2010, so thanks for the new network. So new network here we will discuss later. They have a new branch called deep learning. Okay, deep learning here, deep learning. Okay, and stands for the GPU, graphical processing unit. So and we have the new breakthrough about the AI, about the machine that they can deal with. So if you still remember at that time, 2010, we have AlphaGo. Okay, we have AlphaGo here, AlphaGo. So AlphaGo, they start to deal with the Go. Okay, so this one is the Go game. Okay. So Go games, they say that there are lots of possibility. And then if you only use the if-then rules or traditional machine learning method, definitely you cannot find the solution in a very short time. But with the power of AlphaGo, they try to combine the deep learning with computer visions and of course with a reinforcement learning. So they try to solve the Go problem, and then they can find out a best solutions, optimized solutions in a very short time. And finally, it win all the Go game, even the top player in the world. Okay, so this is how it's a breakthrough of AI system, and then it turns out to a new age how the computer or how the machine learning is broadly used in our daily life. So in our project, we are using deep learning here, okay? So it's only a subset. So it's a subset of neural network, and neural network is a subset of machine learning, and machine learning is a subset of artificial intelligence, okay? So again, what is machine learning? Okay, so what is machine learning? In our traditional modeling or traditional programming, so if you are CS or computer science or engineering student, or if you have learned any program before, so most likely we put our data and then we put our program. Okay, we put our program. Okay, so the most likely the program we have if then else. So what you have done in Scratch, or what you have done in Unity, or what you have done in the interface, okay? So you cook some if-then-else model. So we put both our if-then-else models and then data into the computer, and we got the result, okay? So this is called traditional modeling, traditional approach. In machine learning approach is quite different. Okay, it's quite different. Okay, so we put the sample data, okay, and then we also put the expected result. Okay, that means here this is the set of the data that we have collect. Okay, that we have collect. For example, if you are working in a computer visions, okay, okay, you want to recognize whether this one is $100 or $10 or $50, etc. Right? So you put the $10 and $100 in the front of the camera, and then you capture lots of the image. Okay, so the image is the sample data. That image is sample data, and then you tell the computer this one is $100. So this one 100 is your expected result. Okay, is your expected result. You put all the things inside the computer. Okay, inside the computer, and then the computer will help you to build the if then else. Okay, that means the model. Okay, that means the model. In traditional programming, you build it by yourself, so model is here. But in the machine learning approach, the computer helps you to build the model, so the model is here. Okay, the model is here. So once the model is built, okay, so when there is a new data, for example, you use the camera to capture the new image. For example, you put $100 again in front of the camera. Okay, by using this model. Okay, you put the new data and a new model, and then computer will tell you that whether it's a $100 or whether it's a $10 or not. Okay, so this one is machine learning approach. The scientific approach, okay, is a scientific approach, is a algorithm that provide the computer the ability to learn, okay, to learn without being programming directly. Okay, that means you do not need to build your if then else. The computer helps you to build the if then else case. So this one is machine learning, ML. Okay. Machine learning is very trendy, so there are lots of killer applications after 2010. Okay, after 2010, just after the AlphaGo. So it can be used in lots of different areas. For example, or the one of the most important killer application is the social media. Okay, social media. Machine learning learned how you interact with the image, how you interact with the videos, how you interact with your fans. Okay, they analyze the content of the post, they analyze content of the image, they analyze the content of the videos. Okay, and then try to do a matching. Okay, try to do a matching, and then give you lots of the information that you want. Okay, and you continue to watch this kind of information. Okay, so this is what the machine learning is performing inside the social media. It's also used inside the transport. Okay, so here is Tesla. Okay, Tesla is one of the I would say that's one of the most trendy things, right? So at the very beginning, we think that Tesla is not perfect. Okay, the battery of Tesla is not really good compared with other for example, other Benz or BMW. Okay, their battery is really bad. Okay, but what they are doing, they are providing good user interface for you. Okay, good user interface. Okay, and they also collect the data from you. Okay, the data from you, and then they try to do the auto driving. Okay, so why people love Tesla? Because Elon Musk always creates some crazy idea, wherever it's Skynet or wherever it's SpaceX or Tesla. Okay, they always create some crazy idea, and one of the crazy idea is the auto driving. Okay, it push how the machine learning or how the AI can help the others to do their work. Okay, and of course other kinds of application. For example, e-commerce. So this one is Taobao. Okay, but not only Taobao, eBay or other Amazons. Okay, they also analyze the shopping behavior, analyze how you interact with the image, interact with the goods, interact with different customer, etc. Okay, so they try to analyze your behavior and provide the landing page for you. Okay, provide the landing page for you. So don't think that because it's e-commerce, or don't think that because it's a virtual, so it do not need to care about the space. Okay, if you are in the shopping mall, you really care about the space inside the shopping mall, because you can put limit goods inside your shop. Okay, so you need to select the best one for the shop. Inside the this kind of e-commerce, you still have the same problem. Okay, people spend on the landing page, or people spend on your website. The time they spend on your website is limited, so you need to push the correct information to them. Okay, so the machine learning also analyze your behavior, and then analyze these kind of things, and then put it inside in on your landing page. Okay, to help you to select the goods, or based on your interest, to select the goods for you. Okay, it also helps in the virtual assistant. Okay, so here is the chatbot. Okay, today lots of the customer service. Okay, they do not use the real real people for the customer service. They use the machine first. Okay, they use the chatbot. Okay, and then try to handle the easiest. Okay, or the fundamental questions, or the basic questions from the customer first. Okay, they try to handle the common question from the customer. If they cannot handle, they will redirect to a real people to handle this kind of things. Okay, virtual assistant chatbot is one of them. That's why I have told you that my children, they will talk with Siri. Okay, they will talk with the chatbot to get the answer. Okay, so this is what we are enjoying the technologies now, and this is why we use the machine learning, because it really helps a lot. And of course about the financial service, and of course about the healthcare. Okay, so today, so you have lots of the application to discuss to discover the problem inside your X-ray, inside your CT scan, etc., etc. in the financial service. So machine learning try to become a fund manager. Okay, and then all the transaction, maybe they are not handled by real human, by real fund manager, so they are handled by some machine. So they will do some high transaction. Okay, high IO transaction. Okay, so they will buy and sell the stock in a very short times. Okay, and they do not have any feelings about the news. They do not have any feelings about the wording, so they just sensitive to the machine learning model. They just sensitive to the algorithm and to the numeric, to the data. So that's why they can, their performance is better than a real human. So we are using the machine to help us to earn money now. So divide and conquer. We always want to break the problem into small parts, and classify the problem into small part and small part. Okay. So how we can classify the machine learning? Okay. So machine learning can be classified into two big areas. One is supervised learning, and otherwise is unsupervised learning. Okay, of course there are lots of different, for example, different small band, for example, semi-supervised or other reinforcement learning. But here two big area is supervised learning and unsupervised learning. So supervised learning and unsupervised learning, the difference is the input. Okay, the input. Okay, so the supervised learning will provide the sample data, and also will provide the expected result. Okay, just like that, we have used an example about $100, right? We give lots of the image of $100. So this is the sample data, and then we also tell the computer this one is $100. Okay, so this one is expected result. Okay, so we give them the sample data, we give them the expected result for the training. Okay, so this one is supervised learning. For the unsupervised learning, we only give them the sample data. That means the image. Okay, it's a perfect example. We just give them the image, and then we do not tell the machine what is the expected result. So let the machine to cluster. Okay, cluster the image. Okay, and inside, for example, here inside the supervised learning, we can have two different kinds of things. One is called classifications. Okay, classifications, and other is called regressions. Classification means that the output is discrete data. Okay, the output is discrete data. For example, it's the image, right? So the image one is $100, another is $50, another is $20, another is $10 notes. Okay, so they are discrete data. They do not have any continuous or relationship between each image. Okay, each image. So this one is called discrete data. Discrete data, or I will say that your discipline. For example, some of them are from computer science, and then some of them, some of you guys are from um, 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 business. Some of you guys are from social science. Some of you guys are from the other, for example, linguistic department, etc. Right? So you are from different department. Department are also discrete data because you do not have a continuous relationship between your departments. Okay. Regressions means that it's a continuous data. Continuous data. Okay. Continuous data means that they have the numeric relationship. For example, about your height. Okay. Or I'm 170 cm. So you have 171, you have 172, 3, 4, 5, 6, etc., etc., etc. So those are the continuous data. Okay, those are the continuous data. Okay, how tall you is the continuous data. Okay. Yeah, and one more about the discrete data. For example, male and female. Okay, male and female, they are discrete data. Okay. And if you are year one student, year two student, 3, 4, 5, 6, you do not have 3, 4, 5, 6. Yeah, so they are the continuous data. So you have two different kinds of things. Discrete data return true about, most likely return true about the labels. Okay, labels, and it's a classification problems. And then continuous data returns you a value. Okay, so it's a regressions problem. Okay. For the unsupervised learning, so most likely we only care in this course. So most likely we only handle about the classifications. Okay, classification problems. Okay, so we will not handle the others. For the unsupervised learning, so you have two different kinds of problem. One is clustering. Clustering. Okay, so clustering, I have told you that you give them lots of the image, and then the the what the the machine try to help you to cluster the image. So if you have used the series of, you are Android user, right? So you have take lots of the photos, and then the Android or iOS, they will try to analyze your photo, and then cluster your photo. For example, this photo is about the human, or this photo is about, they use the recognition of your face, right? So this photo is from your family member, is from your wife. This photo is from your children, etc. Okay, so this is clustering. Okay, so they do the automatic clustering without you input. This image is the people inside is my wife, is my mother, father, etc. Okay, the computer try to automatically give the label to your photo and then do the clustering. Another clustering, right? Clustering example is about the customer. Most likely customer will not tell you lot of things about their behavior. For example, their age, or the item that they want to buy, or some type of things. Okay, so we analyze their behavior, and then throughout their behavior we try to cluster the customer. Again, we do not have an expected result. Okay, we just want to help them to form into groups, form into different cluster. Okay. And another things for unsupervised learning is about the dimensional deductions. Okay, so if you are handling lots of the data, for you have collect lots of the log data, so there are different column. Okay, so yeah, most likely for a e-business. Okay, for a Amazon or Taobao. Okay, such kind of websites for the shopping, right? They will collect 100,000 or even 200,000 dimensions. Okay, they will collect all the information that you perform inside their websites, even every click on the goods, and then even the information that you have input, or they have collect throughout your behavior, throughout your logs. Okay, so there are lots of data. Lots of data is used. Lots of the data are useless. Okay, so we need to reduce the dimension and filter out the useless column, useless dimensions. So this is how we use the machine learning to do the dimension reduction. Okay, so if you have learned some, if you're a computer science student and then you have learned some algorithm, so definitely if you do the dimension reduction, you use the PCA. Okay, if you do the cluster array, you use the k-mean cluster array. Okay, so so after we have taught about the machine learning, and then we'll taught the one of the subsets of machine learning is neural network. Okay, neural network. So deep learning is coming from neural network. Okay, so we learn the neural networks first. So neural network is inspired by our human brain. Okay, it's inspired by our human brain in 1950 to 1960 something. Okay, so inside our brain we have a huge neural network. Okay, huge neural network. In this huge neural network, so we have lots of neurons. Okay, we have lots of neurons. Okay, compared with the other animals, so our neuron is more complicated than the other animals. Okay, and thanks God, right? So for the other animals, okay, when they go outside from their mother, most likely they have already put lots of the data inside their neurons. So that's why the other animals, they know how to walk, they know how to run maybe 30 minutes or 60 minutes. So their behavior is similar to their father and mothers. Okay, but for we guys humans, our baby, they need to learn 3 years or 5 years, so they behave like their father and mother, and then we need to learn for us, maybe we need to learn 20 years something to put lots of the things inside our brain. Okay, so at the very beginning we have lots of space for us to learn different kinds of things. Okay, and for yeah, different person, they can put different things inside their neurons. So what's happening? So what's happening about our neurons, or what's happening about our learning? Okay, so yeah, of course, we have mentioned before, we need to draw our attention first. Okay, draw our attention first. For example, from our eyes or from our ear, we need to draw our attention. Okay, so maybe we see a bottle. Okay, we see a bottle, and then we put the image of the bottle inside one of our neurons. Okay, inside one of our neurons. And then if we teach them to drink the water, by using the bottle, okay, so we put the water inside another neurons. Okay, inside another neurons. If we repeat this kind of behavior, that means drink the water by the bottles. Okay, so we increase the chemicals connect with these two neurons. Okay, with these two neurons. And then finally, we know that we can use the bottle to drink the water, and this is how we as humans learn the things. Okay, from our attention to short-term memory, and then later on to our long-term memory. Okay, so the computer scientists, they try to use this kind of concept and then use a mathematical model, okay, to simulate the neuron system. Okay, to simulate the neuron system. So you see, so here we have lots of different kind of nodes. Okay, so this kind of nodes is simulate the neurons. Okay, and then we have lots of the connections to connect each node together. Okay, and this kind of connections is just like the chemical simulate here. Okay, but what is the concept in between? Okay, so here we use a working example to try to let you more about how a mathematical model to simulate our process inside our brain. Okay, so here we have two input, x1, x2, okay, and one output, y. Okay, one output, y. So those are the nodes, and then we have lots of the connections between each node. Okay, so this one we call it a fully connected network. That means all the nodes, they are connected with each other. You see that, right? All the knobs, they are connected with each other, okay? And then all the knobs all the knobs here, x1, x2, when they are connected with each other for all the lines that they connect with each other, we will give them a weighting, okay? So here, this line is W1 and this line is W2, W3, W4, W5, W6, etc. Okay. When the lines are connected to each other, and then we will calculate the new value of the new knob. Okay. So the new value of the new knob is the weighting times the input, and then we sum up them together. So here for the x1, we sum up the weightings and x1 and plus the weighting with the x2. Okay, so we put these two lines together. Okay, and then the x2, we have the similar settings. Okay. So when you're looking at this equation, it's only a linear equation. Okay, y equals to mx plus c. Okay, but we sum up all the y equals to mx together. Okay, and become the output. Okay, and this is how we simulate our brain. Okay, so what's going on, right? When we have the simulation, when we have the input data of x1 and x2. Okay, for example, x1 is 5, x2 is 4, etc. Right? So we will assign some random number to all of the rating. Okay, so we assign the random number to W1, we assign a random number to W2, assign the random number to W3, 4, 5, 6, etc., etc. Okay, so when we assign the random value to the W, and then we combine the x1 and x2 together, so we got all the answer of h1, h2, and the estimate output y. Okay, y. Okay, by compare the estimate y. So here I do the calculation for you, right? If you want to do the calculation, you can still continue, but this only a example to illustrate our idea. I will calculate for you. So the estimate y is 0.82. So it's different from the true value. Okay, the true value y is 1. Y is 1. And the estimate value y is 0. Point h2. Okay, so there is an error in between. Okay, of course there is an error because we just put the random number into it, right? So definitely the output that we get outside is different from the real wise. Okay, so it turns out there is an error. So we use the error of the y, and then we use the error of the y to calculate the error of h1, to calculate the error of h2. Okay, according to their weighting. Okay, for the largest number, the largest value of the weighting, they are responsible for a largest error, right? And then we use the h1 and h2 error to calculate the new weighting, w1, w2, w3, w4, w5, w6, etc., etc. Okay. So so after the first cycle of the calculation, so all the random value of W1, 2, 3, 4, 5, 6, they have the new value again. Okay. So with more and more data, okay, so with more and more x1, x2, and y pair, okay. So the weighting of the new networks of this kind of slope, okay, they are close to real values. Okay, they are close to real value. So that's how the new network is learned from your data. Okay, they are tuning the weighting. Okay, there are lots of weightings. Okay, they are tuning the weighting, and then so that's they can minimize the error of the model. So after maybe few thousands of times, they tune the slope of each weighting, okay? And then it turns out a reasonable or acceptable accuracy. And that is how the neural network is learning the weighting, is learning the parameter from your view data. Of course, the linear equation is only a small or fundamental part of neural networks. Okay, we use the linear equations to calculate the things, right? But there are lots of nonlinear approach. Okay, nonlinear approach. So this is another mathematical problem. So inside each of the knobs, beside the linear equations, beside the W and X pair, so we also add some activation function, or we call it bypass function to it. Okay. So we have the sigmoid, we have the tangents, we have the value, okay, maximum, 0 or x, okay. So after, if the summation of all the w and x pass the 0 value, so we return the x, the true weighting, to the output, okay. So value is one of the most commonly used activation function in deep learning or in neural networks. Okay, so if you are computer science student, you need to you need to learn about it. But if you are not a computer science student, so just know that we will combine all the linear equation together, and then by using the activation functions, okay, we can turn the linear approach to non-linear approach. Okay, so this is how the neural network, they try to perform like a human brain. Okay. Of course, there are lots of activation function, and yeah, you can learn it later. And after you have learned the neural network, and now we are here. Okay, we are only here. Okay, okay. And then there are lots of different combinations of the node models. Okay, so there are lots of different node. Okay, and then there are lots of different connections between different node models. When you increase the capacity of the neural network, so we try to go from neural network to conventional neural network. That means the deep learning. Okay, so here is one of the deep learning approach, and here is another kind of deep learning approach. Okay, okay. In our project, we are working in computer. We are working with the CNN. We are working with Squeeze-Lab. So it's these two kinds of deep learning approach. These two kinds of graphics. So how the neural network is transformed from the CNN? Of course, we increase the capacity of the node model. We increase the capacity of the connections. Okay, so why we increase the capacity of the connection and then turn it into a convolutional neural network? Okay, CNN, it can be a deep learning, and then they can do lots of the calculation for me, especially in the computer vision area. So what's going on behind? Okay, so here is one of the image, right? So here is one of the image. So throughout the CNN or throughout the deep learning, they try to extract the feature of your image and then combine the feature together. Okay, combine the feature together, together. Okay, into some abstract form. Okay, into some abstract form, and then we try to linkage those abstract form from a vector and match with the labels, match with the classifications. Okay, okay. So this is how the deep learning is running inside our computer visions. So here is come a easiest way to understand what's going on, right? So we classify them into low level feature, middle level feature, high level feature, etc. Okay. So here is the image, right? So we want to find out some interesting point of the image. Okay. For example, there are lots of the straight line. Okay, straight line inside the image. Okay, we use those straight line as a low level feature and then combine with some bigger, yeah, bigger point in the graphics. Okay, bigger point, bigger area inside the graphics. Okay, and then we turn these kinds of middle level feature to another high level feature to see whether it's a wheel of the car or not. Okay, Okay, if we can find out lots of these kinds of area inside the image, we can say it is a car or is other kinds of vehicle. So this is how the deep learning is analyze the graphics and then combine the feature. Okay, they extract the small parts inside small feature inside your graphics and then combine them together. Okay, and then combine them together. Okay, so they learn about the distributions of your pixel. Okay, distributions of your color. Okay, distribution of your color. And then if they can find the machine learning, deep learning model, they can find lots of similar feature inside your image. They will say that this one is car or this one is table or a cat, etc., etc. This how the computer vision is. This how the deep learning is using in computer visions. And then yeah, one of the CNN is called Squeezelet. Okay, okay, Squeezelet. So again, it's a subset of the neural network, is subset of the deep learning. So Squeezelet is some pre-trained model that you can download and use. So that's why when you training inside the Google, inside the yeah, other kinds of platform as a service, you need not to spend lots of the time. You need not to spend month or even year to train up lots of the image. There are lots of pre-trained model, and then you can use the pre-trained model to add your image inside it. Okay, to add your image inside it, and then you can enjoy a shorter training model, shorter training times with the same accuracy. So the Squeezelet is around 50 times, okay, less than your other neural network. Okay, so it's quite good, and then the performance is good enough for all the webcam, okay, or we call it browser applications. Okay, so that's why we are using Squeezelet in most of our applications because it's really fast, and then yeah, they have the similar accuracy with the other neural networks.